we need to evaluate this limit. It's the limit as x tends to 1 of x minus 1 divided by the square root of x squared plus 3 and then minus 2. Now remember, we have various ways of trying to find the limit, and the easiest, which usually doesn't work but it's worth a try, is direct substitution, right? Now, if that fails, we can look at any quadratic expressions that we could factorize then cancel. If that cannot work, there are other things we could do. We could divide both numerator and denominator by the highest power in the denominator. If that cannot work, then another thing we could do is multiply both the top and bottom of the expression by the conjugate of the denominator. Alright, those are some of the steps. Now remember, one of the things we could also do is to use a value that is close to the limit, but that's not the expected normal practice. All right, anyway, let us see how we can deal with this. Can we use direct substitution? Let's see. When x is 1, what happens? Let x equal 1. 1 minus 1 up top divided by the square root of 1 squared plus 3 minus 2 would give you 0 up top divided by 1 square is 1, 1 plus 3 is 4. So it's the square root of 4 minus 2. But this square root of 4 is 2, so it's 2 minus 2 equals 0 divided by 0. This is in the indeterminate form. So that method failed. So we have to use another method. Can we factorize anything? And is this a quadratic expression? Doesn't seem so. Alright. Now, what I'm seeing here, the way it is set up, you could use the conjugate method. Alright? Because if we multiply x squared plus 3 square root of that by itself, the square root would disappear and it would free us from the square root sign. The x would no longer be under the square root sign. So let's use that method. The conjugate, alright? The conjugate of the square root of x squared plus 3 minus 2 is equal to the square root of x squared plus 3 plus 2. Let's multiply both numerator and denominator by that. So we have the limit as x tends to 1 of, we have x minus 1 up top over square root of x squared plus 3 minus 2 down the bottom here. We multiply it by the square root of x squared plus 3 plus 2 divided by this line is kind of long, divided by the square root of x squared plus 3 plus 2. Let us see how that will help us. We could put them in bracket. Right. Now x times this is going to be x, right? No. In this case, no. Let's not multiply the top. Hopefully, you see, we'll get an x minus 1 under the bottom that will cancel this x minus 1. Let's make the numerator part as it is. Don't interfere with it. We don't want to get ourselves in problem. We might get ourselves in problem if we interfere with the denominator part. It's this part that we want to trouble. So let's keep it. If we interfere with the numerator up the top, it's the bottom part that we want to trouble. So x squared plus 3 here plus 2 divided by, let's multiply this out, square root of x squared times the square root of x squared plus 3 times square root of x squared plus 3 is going to be the square root of x squared plus 3 squared. Alright, multiply itself. And you say plus 2 times the square root of x squared plus 3 minus 2 times the square root of x squared plus 3 negative 2 by 2 is minus 2 2 is 4. Okay. Now the fact that we multiply by the conjugate is going to get rid of the square root signs. Let us see how. You have x minus 1 up top times the square root of x squared plus 3 plus 2. That's the top part. But we see how we get rid of the square root over the x squared plus 3 part under the bottom. This here, the square root sign will disappear because it's squared. So it's x squared plus 3. 2 square root of x squared plus 3 minus 2 square root of x squared plus 3. That is gone. See that? And minus 4. Now, what happens out here? This is equal to x minus 1 by square root of x squared plus 3 plus 2 over. Look at this. This is x squared. 3 minus 4 is 1. Minus 1. Alright. Let's rewrite the top. X minus 1. And by the way, remember, I had left it out here, but it's the limit as x tends to 1 we're looking at. Just to remind us, make sure to put it here. So, this is the square root of x squared plus 3 plus 2 plus 2 over. Look at this. This is a difference of 2 squared. It's x squared minus 1 squared. Let's use the shortcut and factorize this. It would be x plus 1, x minus 1. Alright? Now what do you notice happen next? The x minus 1 here and the x minus 1 here, they cancel. So what you have here is a square root. Let me write the limit. Limit as x tends to 1 of the square root of x squared plus 3 plus 2 divided by x plus 1. Now, let's substitute into this one to see if things work out for us. This, when we let x equal the limit of 1, what we're going to have is the square root of 1 squared plus 3 plus 2 over 1 plus 1. Okay. This is the square root of 1 squared is 1, 1 and 3, 4. So it's the square root of 4 plus 2 up top divided by 1 and 1, 2 down the bottom. Square root of 4 is 2. So it's 2 plus 2, which is 4 over 2. And we get our limit. 2. So I want you to, if you didn't work it out before, I want you to write this down, then try it again without looking at the working here.